Okay, we are on FRQ topic 6, function analysis. Function analysis is very often seen, not every year, but very often seen. These questions will simply ask you to analyze a function in various ways. Okay, they can ask you anything on these. So just don't be rattled. Do what they tell you to do. Okay? No matter what it is. Sometimes it's just finding a derivative, using a derivative, relative mins and maxes, okay, absolute mins and maxes, that's candidate's test. Oftentimes in here, you'll be finding an integral, okay. Improper integrals are really popular in this section as well, okay. Don't forget your average value of a function formula, average rate of change, equations of tangent lines, L'Hopital's rule, show your work. Okay. All right, let's take a look at the first of our examples. This is back from 2016. Okay, no calculator on these. The inside of a funnel of height 10 inches has circular cross sections as shown in the figure. The radius is given by this equation. So they give us a way to get the radius. Okay. All in inches. Find the average value of the radius. Well, that is a very straightforward question. Find the average R. So, from 0 to 10, so 10 minus 0, integral 0 to 10 of this function. So we just need to work out this integral. Now it becomes a, does this student know how to integrate question? I'm going to begin by taking out this 1 over 20. It's just a constant, so I'm just going to take it out. I'm going to multiply 1 over 20 times 1 over 10. That will be 1 over 200. And now I'm going to integrate what remains, little power rule here. 3h plus 1/3 h cubed. And now plug in my values. $30 plus 1,000 over 3 minus 0. Done. Not bad. Part B. Find the volume of the funnel. Okay. Volume. The most general formula for volume is integral of the area of a cross section, right? That's our general formula for volume. What is each cross section? Each cross section is a circle. So that's going to be the integral of a circle, pi r squared, dh, right? From 0 to 10, yeah? Where this is our r. So I'm going to have the integral from 0 to 10 pi r squared. R is 1 over 20, 3 plus h squared, but I square that to get my volume. Pi r squared, that's it. Integral of area, basic volume, okay? So we have to actually work this out. I'm going to be taking out the pi, but I'm also, since this is a product, I'm just going to square each piece and multiply them together. That's how you square a product. So I'll have 1 over 400 times pi. I'm going to take out pi over 400. And now I'm going to square this remaining thing. So I'll have 9 plus 6h squared plus h to the 4th dh. And now all of a sudden it gets super easy. 9h plus 2h cubed plus 1/5 h to the 5th. And now plug in our values. Plug in 10. One, 2, 3, 4, 5 over 5 minus 0, so that's just it. That's it. Okay, I'm feeling pretty good here. Part C. Okay. The funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is 3 inches, the radius of the surface of the liquid is decreasing at the rate of 1/5 inch per second. So dr dt is negative 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? So I want to know what is dh dt. Well, this is not bad at all. They give me an equation for r. And they asked me to find dh dt. So I'm going to take the derivative of both sides with respect to t. I get dr dt is equal to, okay, I'm taking the derivative over here. So first with respect to h, then multiply by dh dt. I'm going to have a constant, and then I'm going to have 1/20th h squared here. So the derivative will be 2 times 1/20th, that's 1/10 h dh dt. That will be that derivative. Okay? Now plug in our values. I want h to be 3. dr dt they gave me was negative 1/5. So I'm just going to solve for dh dt. I'm multiplying both sides by 10, dividing both sides by 3, and I'm done. I didn't think this problem was bad at all, but globally the students did not agree with me. Let's see how they scored this. 1 point in part A, 1 point for the integral, 1 point for the antiderivative, 1 point for the answer. For part B, 1 point for the integrand, 1 point for the antiderivative, 1 point for the answer. That leaves us 3 points for part C. One point for just this piece, just the derivative with respect to h. So they wrote that as the derivative with respect to h is equal to 1/10 h. And then 1 point for the whole thing, dr dt is 1/10 h dh dt. And then 1 point for the answer. Did not think that was that bad. Okay. Let's take a look at the problem from 2017. 2017. Okay, global average was a little bit lower. Let's see if we understand why. Excuse me. Okay, find the slope. Okay, first of all, let f be the function defined by this. There's no story, there's just the function. Find the slope of the line tangent to the graph of f at x equals 3. Slope of the line tangent, that's just f prime. Okay, little quotient rule here. Start at the top, take the derivative. The derivative of 3 is 0. So we'll have 0 minus the derivative of the bottom times the top. So I'll have 3 times the derivative of the bottom. So 4x minus 7, all divided by the bottom left alone, but squared. And now I plug in 3 for x. And I'll just say stop there. Okay. Part B. Find the x-coordinate of each critical point of f in this interval. Classify each critical point as a location of a relative min, max, or neither. Alright, critical point is when f prime is 0 or undefined. F prime is 0 or undefined. So, I know what f prime is. I found it in part A. F prime is 0 or undefined. That's what I want. Finding out where it's 0 is easy. I need to take a look at what makes it undefined. So f prime is undefined when 2x squared minus 7x plus 5 is 0. Is that factorable? Let's see, 2 and 7. I think it is. 2x minus 5, 2x minus 1, no, yes, no, hang on, no, that's not right. Is this factorable? Oh, not 2x minus 1, x minus 1, good grief. Okay, there we go. Yes, so 2 and negative, yes, that works. So this is 0, so x is 5/2 and 1, but those were our boundaries here that they gave us. So I don't need to consider that. Okay? F prime is 0 when the numerator is 0, right? Negative 3 times 4x minus 7 is 0. Well, that is 0 when this 4x minus 7 is 0. That means x is 7/4. So critical number is x is equal to 7/4. Let's put that on a number line to find out, is this the location of a relative min, max, or neither? And I'm only examining from 1 to 5/2, right? So let's see. If I plug in a number between 7/4 and 5/2, in other words, greater than 7/4, if I plug in a number greater than 7/4, this piece will be positive, but I'm multiplying by a negative 3, so this will make it a negative. This piece over here, if x is less than 7/4, this will be negative times a negative is a positive. So, at x equals 7/4, f has a relative maximum, since f prime changes from positive to negative at x equals 7/4. Part C. Okay, using this identity that f, this is f can be broken up into these two pieces. Evaluate this integral. Here we have an improper integral, so I know this was a BC only question this year. Okay, evaluate that integral or show that it diverges. So I have the integral from 5 to infinity of f, but they tell me to use this for f. So I'm going to do what they told me to, and I'm going to use that. They have done the partial fraction decomposition for me. They've saved me a bunch of work. Now all I have to do is use what they say to use. Okay, I can dive in right here and take the antiderivative. But since the top boundary is infinity, I need to write this as the limit as something, I'm going to call it b, goes to infinity of. The top is 2. This is a natural log because the bottom is linear. It's a natural log. But the derivative of the bottom is 2, right? So I need to multiply that by 1/2. If you do a u sub, you'll get that 1/2 there. Just like that. So that's the derivative of just this first piece. Minus ln absolute value x minus 1 from 5 to infinity. Well, clearly this 2 and the 1/2, they reduce out. Okay. Oops. Do not put infinity up there. Put a b up there. Sorry about that. That would be a no bueno thing. I would lose a point if I did that. Okay. The 2 times 1/2 is 1, which means I can combine these, and I need to combine these logs because I'm about to plug in infinity, right? I have to combine these logs. Otherwise, you get infinity minus infinity, which is indeterminate. So I'm going to combine these logs and make it ln of the absolute value of 2x minus 5 over x minus 1. Now I'm going to plug in b for x and let b go to infinity. So if I plug in b for x and let b go to infinity, this fraction is going to 2 because the -5 and the -1 they are irrelevant, and the rest reduces to 2. Okay, so I will have ln of 2 minus, now I'm plugging 5 in for x, ln of 5 over 4. That's it. Excuse me. Goodness. All right, part D. Determine whether the series for f converges or diverges. State the conditions of the test used. Okay, well, I just showed that the integral converged. Therefore, the series converges by integral test. I just need the conditions for the integral test, and I'm there. What are the conditions for the integral test? F of x is positive, continuous, and decreasing for x greater than or equal to 5. That was our boundary there, right? And that is our boundary here, yeah? The integral from 5 to infinity of f of x converges as shown in part C. Therefore, the series for f converges by integral test. But I don't have to say by integral test, but that's what it is. Okay, let's take a look at scoring on this one. For part A, well, let's see, 1 point for f prime of 3. So in essence, just for the answer. Part B, 1 point for the x coordinate, the 7/4, 1 point for relative max with justification. So 2 points for part B. Part C, I'm going to put this down here. Part C, 1 point for the antiderivative. 1 point for the limit expression. 1 point for the answer. Okay? Okay, and clearly I have this wrong because I'm not coming up with enough points here. I'm only coming up with 8 points. So I need to go and take a look at this. In class I'll fix that for you. Because in part D it only shows 2 points for the answer with conditions. So clearly I'm missing a point there because every one of these was 9 points. But I'll fix that in class. Alrighty, so that's a couple of function analysis problems.